Welcome, everybody. Looks like I hope they know to let more people in. But welcome, everybody. Ram Ramanathan, product manager at Google Cloud. Along with me, I have Juyun Lee, who's a software engineer in our research organization. And also with me, we have Lynn Urwitz, who's a developer at one of our favorite customers, Wix.com. So the goal for this session is to help you find cats in videos. That's really all we're going to talk about in video intelligence. How can you find your next cat video as easily as possible? Because as you guys know, the internet is all about cat videos. And so the thing that we're trying to talk about is, jokes apart, the goal for this is really thinking about how can you make sense of dark content, as Fei put it. How do you find your relevant entities in video content? How can we help you find potentially, if you're thinking about a media organization, like an example is how Google Play can automatically detect appropriate actresses in videos, etc. So how can we help you do some of the scenarios? Video content is exploding every day, right? I think there was an article last week talking about how every day people watch over 1 billion hours of video content on YouTube every day. And you can imagine, and there's an article in Cisco, Cisco actually an article sometime back talking about how by 2020, 60 to 70% of all traffic on the internet is going to be video content. Well, how do you make sense of that? How can you, as an organization, start harnessing all this video content that's flowing through? Sometimes content that you're publishing, content that you have access to, and sometimes it's content that you're distributing. How can you make sense of this video content so you can get metadata and do things with that content? Clearly, people have been doing things with structured data for a long time, right? BI and data warehousing has been in the marketplace. People know what to do with BI and data warehousing. How do I think about querying data? How do I find relevant entities? How do I walk through a lot of these pieces? A lot of these aspects are something that people do today already in structured data. But for the most part, video content has been something dark. People have not really played with it outside of consuming it. And really, the goal for this session is how do we enable you to do that? So here's, for example, how do you find your favorite dog in a consumer video? Or how do you find a video of a sports event across your petabytes of video content if you're a media organization? How can we enable you to do that? And that's really what we're going to spend some time talking about. Another aspect that you guys can imagine more and more is people are now more and more video content is not actually professionally created content, but it's actually crowd-created content. People are same way as images have exploded on mobile cameras, people are now creating more and more videos on mobile devices. So we want to start understanding these this content from these devices, and so you can start driving better recommendations, better ad targeting, et cetera, et cetera. And that's really the goal, is how do we do that with video content? So Google provides a pretty broad platform for machine learning. We'll spend a couple of cycles on this so you guys get a context of where we're talking about today. So as an organization, at one aspect is we provide you a platform where you can build your data to Google Cloud. You have set of data scientists in your organization. They can then build their own machine learning model using TensorFlow. And then we provide you a managed service runtime using our Cloud ML engine. So in this case, the case on the left is really your data, your model graph running on Cloud ML using an open source framework. The one on the right is really thinking about how we can use some of our own Google internal models that apply the very targeted scenarios, and how you can use that to harness that. So that's really targeted more at app developers. So basically, in the case for vision, we've used models that power things like image search, models that power things like Google Photos. We've exposed that as an API, and so basically you consume that with minimal customization. And so the new API we want to spend some time talking about is our Video Intelligence API. So Video Intelligence API is all about how you can help use Google models that power all first-party Google products like YouTube, Google Photos, and how you can harness the same technology for your own unique scenario. So what are the key use cases that we're trying to solve for video intelligence? Really, we're thinking about 3 main things. How do you find the main topics of what the video is about? So for example, what is a video about? What are the key relevant entities within a video? So those are really that's kind of think of the fundamental use case that we're trying to solve for first. The second big use case is, if anything, Vision has told me is many organizations really want to monitor inappropriate content, especially if you think about you're a crowdsourced platform and there's a lot of people uploading content into the device. How do you monitor and manage what the inappropriate content that flows through? And that's a key use case that people have to deal with, especially when you start dealing with crowdsourced content. And the third part is, how do we find the most relevant moments in a video so you can start publishing it? Unlike a document, unlike an image, if you have a 10-minute long video, how do you entice somebody to watch that video? Right? So really thinking about highlights and thinking about video previews is a pretty key problem in the video use case. And that's another scenario we'll talk a little bit about. So really, the three-part things we're going to talk about is how do you find the right entity in a video, or what the video is about, how do we moderate inappropriate content, and how do you think about finding the best moments within a video. So let's start off with the first aspect, how do you find entities? So really, we have a feature in the video intelligence API called label detection. Right, so label detection is basically we have label detection in Vision that applies primarily on images, and now we have label detection on video content. So its goal is to find thousands and thousands of different entities in video content. These entities can be things like everyday objects, from chairs to things to activities like running, jumping, falling, or even things like scenarios like how do you think about everyday objects like cars, transportation, etc. And we'll talk a little bit about those entities later today. And how do you call this API? So really, the thing is, you pass in a URI, which is basically a GCS location, or Google Cloud Storage location for where the video is. And then you can also tell it where do you want to write the output to. So it's really the one caveat I want to make sure you guys leave with. In V1, we're really focused on batch scenarios and not real-time streaming scenarios. So really, it's whereas you have a piece of video content on Google Cloud Storage that we read from and then we write back to. So there are lots of other streaming scenarios that you can imagine that we're not solving for that in V1. It's clearly something we're thinking about down the line for future versions. And the other part that we want to spend some time on is I'll talk a little bit about is what do you want to see in a video and when do you want to see in the video? So we give you a couple of aspects. We give you things like video level annotation that tells you this video is about blah, right? So what is this video about? And then the second part is when in the video did something occur. And for that, there are different ways you can do that. There are things called, what we have called shot mode that tells you, tell me things relevant to the shot, and the things that are relevant at the frame level, which is basically just applying Vision API on a frame-by-frame perspective. And we'll talk a little bit about the differences and when you would use A versus B. So the response that you get back, and we'll spend some time on this, so really the thing that you get back from us is we'll tell you the entity, so what the entity is about. Right now, all the entities are returned only in English. Our goal over time is to support additional languages. And then we tell you where in the video something occurred. So we tell you first the level, whether it's at a video level entity, meaning this entity is really defined at what the video is about, or whether this video occurs at a certain shot, in which case we tell you the start and end time, or we tell you, or if you want to do a frame level entity, we'll tell you it occurs at a certain frame. And one of the things I want to spend some time on the next few slides is why do we give you so many options? Because understanding video content can be a little complicated, and that's the reason why we give you all these different permutations of content coming back at you. So the first thing we talk about is how do you separate signal from noise? That's one of the reasons why we do this. Because the challenge with video content is if you run an hour-long video with let's say, a shot changes every minute or so, meaning that the camera angle goes from looking like this to looking like this. So you can imagine that's a shot change, right? The entire camera changes. Those kind of scenarios, if you think about an hour-long video where it changes every hour, every minute, so that's roughly 60 shots, right? The question is, what do you want to understand out of that? So depending on the level of granularity, depending on use case, people think of different things. So the first thing we do is we give you a video level entity. So what is it good for? So it's really focused around, this is kind of truly where that's where we talk about more than just a frame level annotation, meaning that we just don't use Vision API to look at something and give you results. We're actually doing additional machine learning logic on top of each frame. And Julian was going to spend some time about that. But one of the caveats is this really applies only when the entire video is about a certain thing. And it's really optimized for scenarios where it's short-form content, meaning between 1 to 5 minutes. Right? So if you give us an hour-long TV show, and you say, hey, give me this video level entity, it's going to give you very high-level generic entities. And that's something you guys should be aware of. because the video level annotations really make sense more for short form content. The other aspect is shot level annotations. So think of a shot as a mini video, meaning that it's kind of grouped together based on the shot change, and it's almost as a mini video. And this is kind of a first level temporality. So we'll tell you when in the video something occurred, and we'll kind of group it at a shot level. So we tell you the start and end time of the shot. And within that shot, we'll tell you these are the most relevant entities in that shot. So where is that kind of comes into play? You can imagine, especially when you have let's say you have an hour-long TV show. You really want to, there's going to be a lot of context switching in that TV show, right? People are going to be suddenly talking inside. People are going to be going outside. Each shot has a different set of relevant entities. And what you really care about, tell me is exactly what's relevant within a shot. Because otherwise, you're going to be dealing with a lot of noise coming at you. Because, for example, we'll talk a little bit about an event later where, for example, we have a video about, say, I am talking right now. And if somebody does a frame-level annotation, they're literally going to get the same set of entities every frame, every second. That's a lot of noise coming back at you, right? So that's really where shots really help you there, because it's going to basically aggregate that information and say, hey, guess what? This is what's really relevant within this video. So you're not dealing with all that noise coming back at you. That's why it kind of goes back to is separating signal from noise. And the other value is that over time, we also can start adding additional signals. So we can start adding not just visual signals, additional signals can flow in to tell you what the shot is about. And Julian will cover a little bit about that later. So this is where this is really thinks about context switching. So think about news shows, TV shows. Think about aspects like for example, even basically the video we showed at the keynote demo from Sarah did, like an ad that has multiple different context switching. A shot-based entities will be very relevant in that scenario. And finally, we have the lowest level granularity, which is frame level. So frame level is really thinking about, there's no additional ML logic. It's really just taking every frame at 1 FPS, and you're banging against an image detector and saying, hey, what do you see in this frame of the video? Right? So there's a little less logic, a little less intelligence in this aspect. But there are a lot of scenarios where this makes sense. For example, there are a lot of scenarios in, say, surveillance where the video is not moving. It's always pointing in a certain direction. And in which case, if I do a shot change, there is no shot change. This video is always one shot. Right? So that way, frame-level entities make a lot more sense. The other thing is consumer videos. For example, if it's a long-form video and you really want to get you want to understand exactly what's happening at a much more granular level and even at the shot level, some of these frame-level entities make sense. So this is cloud, and I kept reading a lot of tweets yesterday saying there was not enough demos at the keynote. So the goal today is to show you guys some demos. So if we switch to my demo machine. And if I can actually log in. OK. So by the way, the whole goal for this session is how do I get back to BigQuery? Because I love BigQuery. So my goal is at the end of it, I'm going to head back in BigQuery. So first, let's first go with this video. So in this case, this is a video about sorry, let me just refresh it. This is not a good sign. I can't believe this. OK. Well, that's coming up. So for example, let's go to this one. So in this case, this is an ad. This is an ad for one of our Google Fibers. We're basically just pulling ads from a Google channel. As you can imagine, videos have a much higher rate of copyright infringement, et cetera. So we're primarily using our own Google content. So in this case, we're just showing you an ad of this is an example where context is switching a lot. Right? It's an ad, so you can imagine every 3 or 4 seconds, you switch context on this pretty significantly. And we basically, the key aspect is we're showing you how this changes. So for example, so what you can do is basically draw a list of all the entities that are in this video. Right? So for example, in this case, this is primarily our entire JSON dump of every single entity that we detected. We tell you the shot level, video level about this entity. The one gap we have here is, for example, because it's changing context so much, our video level entities don't add a lot of value. Does that make sense? Because you can imagine which going things from outside to inside, and a lot of things changing around. Over time, you can imagine as we improve our video models and we start taking in additional signals to our video models, we can pick up additional signals to make our video classifier more smart. And that's something we are constantly working on. So in this case, for example, we find a car, we tell you exactly the short boundary where the car is. And the other aspect is, for example, we see house, homes, a lot of different pieces that's driving through here. The other thing is, for example, we know in that aspect we're actually in a car because the scene is changing so fast. So the video model actually detects that we're in a car and kind of driving that scenario. So cottages, so you can imagine common scenarios. So you can, there's a lot of use cases where we drive that. So let me see if I come back to this case. So in this case, this is a video about what's going on inside a zoo. Right? The entire video is actually happening inside the zoo. It's a nice, friendly video about animals. So in this case, our video level entities actually makes a lot of sense because we're not changing context for the entire time, right? It's a homogeneous video about a tour of a potential wildlife thing. So we can actually find out it's about a zoo, it's wildlife, it's tourism. It can give you much more relevant video level entities in this case. But we also can do things like short level entities. So in this case, we can look at these pieces, and you can imagine each of these slices are shots. Again, this is an ad, so the shots in this video are changing constantly, right? You're going to go every 5-6 seconds, it's changing a lot on you. And so you can imagine as we go from shot to shot, we start telling you all the different pieces that flow in. And a couple of things that's relevant if you think about digital marketing scenarios, right? It's a zoo video. But there are a lot of things about mobile phones and devices in there. So if you're really trying to mine the data to see what are all the entities in there, this is a good way to kind of capture that information. Because you would never have thought, why would I see a mobile device in my zoo video? So here is another aspect of a long video. For example, in this case, it's actually a video of Feifei giving a speech at a conference. And this is an example for where the number of shots in this is actually not that many, right? There's a lot of shots. For example, in this case, she's actually standing in one place for pretty much the video follows her for a full minute. And so you imagine there's really no shot changes in that. So it's actually just about her talking. So you can imagine where a frame level annotation in this context will be extremely noisy. Because you're just going to get bombarded with 60 frame annotation that tells you exactly the same thing. It's not really relevant anymore. And that's where short level aggregation is kind of useful in that aspect. And that's also a unique proposition from a video perspective, we think, compared to some of our competitors in the marketplace today. So that's one aspect. So what can you do with all this metadata? And as I said, my goal is always to come back to seeing, if you go back to the scenario around how we thought about structured data, how do we enable these things that real structured data is, all of this is just JSON that's flowing through, right? So you can imagine we can start basically making this JSON, flatten this JSON. It's a simple, so you can take this JSON out, flatten it, and then load it into BigQuery, right? And now that it's in BigQuery, I can do things about, I can just write a regular SQL query like I would do everything else. So now I want to understand, for example, in this SQL query, all I'm trying to do is, hey, tell me for all the shots, what's the most common, by scene, what's the most relevant entity in all my shots, right? So I can do a simple SQL query, come back, get that information out. So really what I'm trying to do here is I've basically taken all this video metadata, taken all that, plugged it, did the video API, and brought it back into BigQuery and run SQL queries. As I said, the world revolves around SQL. Nobody got that joke. Sorry, been in SQL Server for a while. Here's another example of that. So this is kind of things that you can imagine you can easily do with video intelligence. That's really the value that we're trying to do, is we're trying to start making sense of all this metadata that you have in your organization. So you think about, you now have petabytes and petabytes of video content. You can run it through video intelligence, start harnessing those entities, flow it into a database, and start to actually think about how you can now index your videos more intelligently, feed it to your media portals, feed it to your query engines, doing analytics. Think about scenarios where you can now correlate the entities in the video to potentially ratings. So you can figure out when certain shows are going bad based on ratings. And you can try to which entity were people looking at. So you can start doing more interesting scenarios where now that you have this as metadata, you can do a lot more interesting scenarios on correlation, driving into downstream machine learning models, etc. Back to slides. So with that, I want to ask Julian to come on stage. Julian's going to talk a little bit about some of the underlying technology that we're doing, and also talking about where we're thinking of taking it down the road to.
Yeah, you don't get the transcript. It should be. Oh, okay. Right. Hi. No, actually, let's go back. Right. So hi, I'm Chihan from the video intelligence team. I'm a software engineer in machine perception, which is an organization under Google Research. And our mission is to make machines understand unstructured data, such as video, audio, images, etc. I'm here to explain what's going under the hood, so that it doesn't look like the wall of Google is selling black magic to customers. So given a video in your GCS bucket, the first thing that we do is we decode the video. And usually a video container contains audio stream, video stream, subtitles, and all other metadata. And we are first only interested in the video stream. And a video stream is often a sequence of images, a lot of them. For 5-minute video at 24 frames per second, you will have 7,000, 8,000 images in them. And they will probably in sequence look a lot similar. So classifying each of those is not too efficient, let's say. So we subsample the images and say at 1 FPS, so 1 frames per second, we apply an image classifier. An image classifier that's very similar that you can get through the Google Cloud Vision API. And we do it for every image in the entire video. And for each frame, you will get image features such as this elephant with 97% accuracy, or animal, or river in that case. And if you keep going on, you will get other labels for crocodiles and lions. And at the end of the video, what we do is we have an aggregating video classifier. And this is really what sits at the core of this particular API. And this, given all these features throughout the entire video, it will then say, hey, this is a documentary about animals in Africa. Another a similar example would be if you have a video of people in costumes or pumpkins and candies, this classifier will be able to tell you, hey, this is a video about Halloween. And this is only possible because we have trained this model on millions of YouTube videos, and human rated and also verified. Ram talked about also the shot level annotation a minute ago, and those are essentially treating each shot as a mini video and then running essentially the same logic. Of course, there's more machine learning and computer vision techniques involved in this. And I just very briefly summarize this, but you're essentially getting what's behind YouTube and photos with this release. So far, I've only talked about the visual features, but we are also considering adding audio or motion or speech or subtitles to this classifier and do the final fusion in this aggregating classifier. So that you don't assume that you have a video of an animated music video. It would be sad if we give you a label saying that this is an animated cartoon. You definitely want the audio signal in there. So we are looking at various other signals to improve the quality of the model. And one thing that I wanted to emphasize is with this release, we are not keeping the models as is. We are constantly improving the model, especially when Google internally releases a new model for their YouTube photos. Then we also update the models for the Google Cloud Video API. And also, your feedback is important. Your feedback may you be happy or not so happy. Those will be incorporated in the next releases. So yeah, feel free to reach out to us to improve. All right. Now I have, yeah, that's about like leaking the secret recipe that we have. Now I'm going to talk about a little bit about what's coming next, a preview on video previews, also known as like video summaries or like thumbnailer. So assume that you have a bunch of customer videos and you have to show it in a list. You need to make a listing page. Now you need thumbnails for each of those videos. Now, how do you pick the right video frame for the video that you don't know about? You could pick the first frame in the video, or you could apply the Wadsworth constant and skip to 30% into the video and show that frame. At Google, we use machine learning, and what we do is we have a machine learned classifier that tells what's the interestingness of this particular video frame as a thumbnail. So we ran it through like a lot of YouTube videos, human rated and also verified whether these are like actually positive with A/B testing. And yeah, so here on the screen you can see videos, the link to the YouTube video actually. And in the middle column you see a static thumbnail. So the single frame that has the highest interestingness score. And on the rightmost column you see moving thumbnails. So what's the most interesting 3-second clip of that video based on the machine learning classifier? For example, let's show the Earth view in Google Maps. So this is a video when Google Maps released the Earth view. And this is the corresponding static thumbnail and the dynamic thumbnail. Or, so this is when we announced the Cloud Vision API in December 2015. The whole video is about presenting what Cloud Vision API can do, and a demo on this small little Raspberry Pi robot. So it correctly picks up with the interesting thing, the only thing in the video, or like the moving thumbnail. One thing that you may ask is why is the static thumbnail not a subset of the actual animation on the right? And that's because the two classifiers are doing like completely different things. For example, the rightmost column also incorporates motion in deciding, oh, should this be the moving thumbnail or not, whereby you cannot do that in a static thumbnail. So yeah, with that, let me hand it back to Ram for like more use cases.
So if you just go back to 1 second on that, right? I think a couple of things that I really loved about this demo is that this Cloud Vision API was really all about the robot. And it's the fact that it picked up that the key thing about it is actually about the robot, the Raspberry Pi little robot that shows up. It's actually pretty unique because it kind of somehow figured out that this video is really about how we think about Vision API applied on a robot on a little Raspberry Pi, and figured out that's the most relevant thumbnail to pick up. It's actually, I mean, if you think about this problem, if you go back to the slides, if you think about this problem for an organization that's building media portals and people are dealing with millions of video content, or even if you have petabytes of content sitting in your media archive, how do you consume it? And that's really what we're thinking about. How do we make life easier? So there are two use cases I'm going to spend some time talking about. First is thinking about content recommendation. So what I mean by that. So for example, you think of this as a mini YouTube. Right? Clearly not YouTube, and it's pretty sophisticated infrastructure. But think of a YouTube where basically you have a set of videos on Google Cloud Storage. You want to start deriving some metadata on this video. It then flows into potentially BigQuery to do some analysis. And then there's a bunch of data analysts that look at this content, do some queries on that, and then they create some features, they feed it into a cloud ML model to drive recommendations. At the same time, they're collecting things like clickstream behavior to drive the scenario, and it kind of flows through that thing, right? So it's really thinking about a very common recommendation scenario. But how do people actually do that? So here's a public research paper that YouTube published some time back. So in this case, think of this video corpus. This video corpus is based on billions and billions and billions of videos that people load into YouTube. And me as a user come into YouTube to figure out what to watch. Right? So the first thing people actually have to do is something like collaborative filtering, where they're really thinking about how do I apply what's the a set of hundreds of potentially targets that we can show to the end user. Right? So that's really where people are thinking about pretty sophisticated TensorFlow-based models to really think about that collaborative filtering to drive that scenario. Then the next thing is really you want to think about is how do I then do ranking? So out of these potentially hundreds of content, what's the 25 that I show to the end user right there? That's where they apply second downstream models that then sort of do a kind of scenario around ranking. But key aspect to keep in mind is to drive both these machine learning models, they need to get video features to flow in, right? They need metadata on what the video is about to do the recommendation. Because the recommendation is both user behavior and metadata about the video. And how do you get metadata about the video? You have to use something like video intelligence. Right? That's another aspect. The other big scenario is media portal. Just take another example from the world of thing is, I have millions of content. I want to start exposing content in a lot of different interesting ways. How do I do that? That's where some of the things that Juyun just pointed out around thumbnails, around kind of just moving images really start coming into play on video summaries. Right? You just can't show a 2x3 pixelation view of a video and expect people to click on it. What you really want to do is start enticing them to click on that. How do you entice them to click on a video? You have to show what's relevant in the video as a thumbnail, because people are drawn visually. They're going to first look at something and then read the captioning. Very few people are going to read the captioning first and then look at an image. Right? So you want to make sure you're showing the most relevant image of that video. And then you want an easy way for someone to get a feel for what that video is about. That's where those things around moving images come into play, because you really want a way for an end user to kind of hover over a video and get a really quick glance of what this video is about. And then you draw them to the actual video. Right? That's why these kind of techniques, when you think about building media portals, video previews, really starts coming to play. With that, what I want to do is, so those are two use cases I talk about: recommendations, media portals. There are lots of other scenarios that we want to enable with this, but you think about a lot of customers thinking about how they drive media workflows. One of our customer references is Cantimo. So they're really thinking about how they use metadata from these videos. They drive it into the media workflow engine. So they enable media publishers and media organizations to drive media workflows based on entities that flow in. Right? One other customer who's going to come on stage earlier is Wix.com. Wix is one of our favorite customers. They've been with Google Cloud Platform for many years. They were also an early partner with us in the Vision API. They're part of our journey Vision API. They were actually on stage same time last year at GCP Next. We're talking about how they use Vision API to drive interesting scenarios in their organization. But as you're looking about the launch of the new media portal with Wix Media Platform, they've also been an early adopter of our Video Intelligence API. So with that, I'd like to invite Lynn Hurwitz from Wix.com to talk about how they're using Video Intelligence API within their organization.
Thank you. Thank you very much, Ram. It's a pleasure to be here. My name is Lynn. I'm a developer at Wix. And I'd like to start with a quick question. How many engineers would you think it takes to create a great website? Very good. The answer is 0 if you're using Wix. For those of you who don't know Wix, let me explain. Wix is a company that allows everyone to create their own great website, providing them with the simplest tools to do so. Now, in this day and age, in order to have a really great website, what you need to do is to have high-quality media in it, and a lot of it. Now, what Wix has to do also is support our whole 100 million users who upload millions and millions of files each and every day. So, as you can imagine, in order to support all this, in order to process all this, we need a very, very strong infrastructure. And we did develop one. We call it the Wix Media Platform. This is what I'm going to talk to you about today. I'm going to tell you how you can use it, not only Wix. Each and every one of you can use it, everyone can use it, and I'm going to tell you how you can build your own media portal on top of it. So, for example, meet Felix. He's a chef, entrepreneur, who wants to build the next big thing. Now, he has this great idea to build a platform in which people gather up, study, and teach how to cook. So he decided to do it with the Wix Media platform. First things first, his whole platform is so focused on users. So obviously, he would like to have user profiles, and he'd like to have profile images in them. Now, from his experience, he does know this kind of thing requires file upload, image manipulation, and he was really happy to see that the Wix Media platform does everything for him. You can upload, using the media platform, every kind of file, specifically images, of course. And when you actually upload an image, it automatically goes through the image API, through the Vision API. Now, the Vision API generates different labels for this image. I'll talk about that later. And also, it can detect faces from the picture. When you already have the face detection, now all left to do is just have the image manipulation. In this case, we're going to use the Wix Media Platform image manipulation tool. This tool allows you to do pretty much every operation you probably know from Photoshop, but you do it on the fly. So what we do here is pretty simple. We just crop the image, resize it, and bam, you have your picture and it's ready for use. Now, I'll take a minute just now to stop everything and explain what's going on around behind me. As you can see, we're in the Wix Media Platform dashboard, and you can see that we are looking at demo widgets. This is the playground image manipulation widget that is actually made by Wix. Wix is using it in order for you guys to try it out, see the features of the platform, but it's obviously more something to do with Wix's needs. Obviously, everyone who uses this platform can decide what kind of feature he wants to show out and how he wants to show them. So this is only an example. As you can see here on the left, you can see the different manipulations you can do and everything. And under the image, you can see this HTML tag, probably a little small, but what it does is reveals the REST API used by our platform. You have also different SDKs, more sophisticated SDKs that you can actually do a lot with our platform with. In this case, Felix used the JavaScript SDK. And as you can see, in order to accomplish all we talked about, he only had to write these 3 lines of code. Now, to the next big feature of the system, video tutorials. He wants his cooks to be able to upload videos. We already know the platform allows that. Okay, we have image upload, any file upload. But the real nice thing about the media platform is how easy it makes it to work with videos. You see, the platform provides you with everything you'll ever need for a video, especially if what you want to do is to create a portal, a media portal. What it does is transcode the video to different qualities for you. It creates a short tutorial from the highlights in the movie, and also it creates poster images for you from different scenes in the movie. Now, I'm really excited to say that the Video Intelligence API made it so much better for us, because up until now, we actually made these poster images from random places in the video, but now, thanks to the Video Intelligence, we can know what are the main scenes in the movie, and we can just take the main picture from them. So we have the main poster images, most relevant ones, which is great. So now when we have our videos up and running, yay, we have everything ready to go, right? Not quite. We're still missing something. How can we allow our users to enjoy the content? Think about it. We're going to have such a huge platform. We are going to have such many tutorials in it. How can they find the relevant content for them? So obviously, as you think, we need a search capability. Now, thanks to the Video Intelligence API once again, we have, every time we transcode a video, we also pass it through the Video Intelligence API. Now, this Video Intelligence API, as you can see, provides us with relevant labels for the video. Now, this is great because our platform obviously has the metadata for every file you upload. But using the metadata and the labels together, and we have a great search capability on top of the Wix media platform. Now, the nice thing about this, because we're eventually using Wix, it's also supported in SEOs. So different search engines can also see these results. Now when we have a search capability in our system, a nice way to show it would be using the poster images we have. So Felix here uploaded a video tutorial of spaghetti bolognese, and he has these poster images generated out of it. Now imagine someone searches for Italian cuisine or spaghetti. How can we find the best fitting poster image for him? Well, remember I told you images go through the Vision API and have labels extracted for them? Well, here we go. So we take these labels, see our labels from the Video Intelligence API, match them, and that's it. We can have the best fitting poster image for our search results. Now, another great feature powered by the Video Intelligence API, and I think is extremely important, is safe search. Felix here does not know, obviously, all the users in his platform and cannot control the content they upload. But he can still be very calm and know he has full control on his system because the media platform would mark any offensive content uploaded. That means he can just decide what he does with it. He can let it go, he can mark it, maybe add a warning for the users, or maybe even filter it out whatsoever. It's his decision to make. Last but not least, now Felix would like everyone to enjoy the content. So, well, this is already taken care of. Wix Media Platform takes care of hosting and serving files flawlessly, no matter where your users are, no matter what device they're using. This is thanks to the Google CDN, of course. Now, and that's pretty much it for Felix. But I do want to remind you, this is only an example. The Wix Media Platform is a powerful, versatile tool that every one of you can use yourselves. It allows you to manage your data, to have image manipulation, video transcoding, to tag and label your data and make it searchable, also supporting SEOs. And it serves your data flawlessly. The platform provides you with unlimited possibilities. I invite you to use it. And I'm looking forward to see what great things you'll build. Check us out on gcp.wixmp.com and also today in the Google Cloud Launcher. Thank you very much.
Thank you. Perfect. So coming back to kind of the key use cases, right? Going back to the key use cases we talked about from a video perspective, really want to help you find the main topics from a media perspective, what the video is about, when the video did something occur, drive things around inappropriate content, and really thinking about how you can start highlighting the video, things around thumbnails, video previews, etc. So really, these are the kind of key use cases we're going after now, but it doesn't mean that we're not looking at other use cases. We're constantly evolving the product, and part of what we call a private beta is to get more feedback from folks like yourselves to start playing with the API, so you can tell us what else to add. Right? What are the gaps? What are the things? That's kind of really why we're trying to go through this private beta is for people to give us feedback and start evolving the product. So you can join the private beta. Just go to cloud.google.com/video-intelligence. You just kind of go there and then you can basically sign up for the alpha. It's going to start onboarding folks next week, basically once I get back home.